Hi everyone. All right, so our next example, a practice example for chapter 8 before we start to talk about quizzing and moving on to chapter 9 is looking at sample distributions of sample proportions. And basically this comes down to two different ways of measuring a value. Sometimes we measure a value when we talk about the mean. And so, the average weight, the average height, the average test grade, and your average. But sometimes it's a proportion, the percent of females, the percent of doctors who prefer this type of medicine, the percent of people that are likely to get this disease. So sometimes it's an average and sometimes it's a proportion. And there are different rules. Some are the same, but there are different rules for proportions and means, mostly when it comes to standard deviation. So before we jump in, I want to remind you that just like with our sampling distributions of sample means, sampling distributions of sample proportions will always have a mean of our sample proportions equal to the population proportion, okay? And again, that means if we were to take every possible sample of whatever value for n, whatever number sample size, if we were to take every possible sample, then the mean of all those samples would end up being equal to the original proportion that was stated. For standard deviation, the formula is different. For sample proportions, we don't need to know the population standard deviation. It's going to be the square root of the true proportion times 1 minus the true proportion divided by n. Okay, so there are formulas. Let's jump right into this problem. Number 4. Okay, a distributor of light bulbs receives a shipment of 75,000 light bulbs from the manufacturer. So in this case, we have a number for our population. There's 75,000 light bulbs. Okay, that's a lot of light bulbs. The distributor will randomly select 1,000 light bulbs. So that's our n value, 1,000 here. A nice big n value. The larger your sample size, the better off you are. And check to see how many arrived broken. So he decides that if he takes this sample of 1,000 light bulbs or whatever, not just he, the person, the distributor, will send the entire shipment back if 3% or more of the light bulbs are broken. Okay, we're going to look at this from two different situations. We're going to say, okay, what's the probability he's going to have to send his shipment back if the true proportion of broken light bulbs is 4%? True proportion is 4%. So it's kind of different with this, and I'll get into that in a second. But then we're going to look at the difference between that and what if the true proportion of broken light bulbs is actually 2%. So in this case, we're kind of changing what we are varying here. In example number 3, our sample means example, and that's not because it was a sample mean example, it's just the way it worked out. We knew the true proportion. Or that's the true proportion. We knew the population mean, and we were like, okay, the population mean is this. And so what value would make us question that mean? And we tested if we received a sample mean of I believe the population mean was 10.5. So if we got 10.5 for our sample mean, would that cause us to question what the manufacturer claimed about the mean? And we decided no, because the probability of getting that was not that low. Then we looked at what would the probability be of if you had a sample mean of 10.45. Well, that is so far off from the 10.5 claim that the probability of getting that in a distribution is so low, we would say no. We would question our claim. We're looking at it differently in this example. We're actually looking at, okay, we don't know the true proportion. We're going to say, okay, he's going to send his shipment back, this manufacturer, if 3% or more of his sample bulbs are broken. So what's the probability that 3% of more of his sample bulbs are broken if the true proportion is actually 4%? And then we're going to look at it also if the true proportion is actually 2%. Okay, so Leading into that, first, before anything, we can't use our normal CDF to determine probabilities if it's not a normal distribution. So what I'm going to ask you to do now is check to see if we can assume a normal distribution. And what we do when we're talking about sampling distributions of sample proportions is we use these two parameters. We need our n, our sample size, times p, our proportion, to be greater than or equal to 10. And we also need n, our sample size, times 1 minus p to be greater than or equal to 10. So right now, determine whether or not we can assume a normal distribution. And hopefully you answered correctly, yes. 1,000, our n value, that's why before I stated like, oh, that's a nice large n value. That's probably going to give us a normal distribution, right? 1,000 times 0.04 is definitely greater than 10, and 1,000 times 0.96 is definitely greater than or equal to 10. So we can go ahead and assume this is a normal distribution, and it's going to be centered around that mean of 0.04, okay? So that's the true proportion of broken light bulbs. What is the probability that this sample of 1,000 light bulbs is going to be more than that, be more than 3% or more, which means he's going to send it back. So that's the probability you're looking for. So what I want you to do right now is use your calculator to find that probability, the probability that a sample proportion is greater than or equal to 0.03 if our mean is 0.04 and our standard deviation is, first answer that question. What is the standard deviation for this sampling distribution? Sorry if I confused you here. When I edit this and add my question, this will be the first question that I'm going to put in. What is the standard deviation? We know that the mean of our sampling distribution of sampling proportions is going to be equal to what we said the actual was, the 0.04. But we have to use our formula for standard deviation. So go ahead and do that right now. Ignore what I just said. You'll find the probability in a minute. First, find this standard deviation. Okay, when you've typed that into your calculator and answered that question, you should get, wrong thing, I didn't want to peek at that yet. You should get 0.006. So that's our standard deviation. So these are the things that you need to put into your calculator, which I showed you that answer, but I'm going to pause this and put the question in my video anyway. What is the probability that if you have a mean of 0.04 with a standard deviation of 0.006, what's the probability that you are going to get a shipment greater than or equal to 0.033% of the light bulbs damaged? Go ahead, calculate that now. Okay, so what you should have done is on your calculator, which I have up here, second VARS, choice 2, normal CDF. Now, this is a greater than or equal to example. So now we have to have a lower bound, and our lower bound is going to be 0.03. And our upper bound is infinity. The issue is on our calculators, we can't type an infinity symbol, so we just put a really, really big number, one with a lot of zeros. Okay, now our mean for this example is 0.04. Our standard deviation, which we calculated, was 0.006. I hope that's right. And enter, 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 enter. And you should get your probability of 0.95. Okay, so what do you guys think? Tell me, do you think there is a high probability that he's going to send his shipment back? Answer that now. And I would say there is a 95% chance that the shipment will be sent back. So yes, he's probably going to send his shipment back. So maybe 0.03 shouldn't be, or 3%. If the true proportion is 4%, Sounds like he probably shouldn't make his threshold 3% that he sends it back. Now, what if we change things? What if we ask the question, okay, if the true proportion of light bulbs broken is actually 2%, what's the probability that he has to send it back? What would the mean of our sampling distribution be if the true proportion is 4%? Is 2%, I lied there. It would be 0.02. Okay. Now, that's the easy one. These are equal. What would the standard deviation be? Go ahead and calculate that now. And we get 0.004. So if we're changing the true proportion in these examples, we need to change the standard deviation because we have different values to put into this formula. All right, we have to check to see if it's a normal distribution or else we can't figure out our probabilities. And so go ahead right now, check that for me and answer. Is it a normal distribution? Yes or no? Yes, because 1,000 times 0.02 is greater than 10 and 1,000 times 0.98 is greater than 10. All right, if so, what is the probability that the sample chosen will have 3% or more broken light bulbs and then therefore will be sent back? So this is what you're calculating now. Go ahead and do that. Okay, so let's see what you should have done on your calculator. You can keep that lower bound of 0.003 and the upper bound of a very large number to kind of get the idea of infinity to our calculator. But now our true mean is 0.02, and the standard deviation that we calculated for this was 0.004. Enter, enter, enter your way through to find your probability, and that's 0.006. Take a minute to state what you think that means about the probability that he's going to send his shipment back based on that. And there is a very small chance, 0.6%, less than a 1% chance that it would be sent back if the true mean was 0.02 and the standard deviation was 0.004. That means like 0.03 is going to be way over here. Very little probability there. Well, hopefully that was a helpful video. Perfect timing because my children are walking in the door. I hope you were able to follow this carefully. If you have any questions, let me know. Send me an email or just make a little comment or post in our Google Classroom. Miss you guys. Bye.